In the vast and silent dark of space, where light is scarce and time stretches endlessly, the James Webb Space Telescope has seen something no one ever expected: city lights. Not just flickers or illusions, but strangely bright, structured illumination, emanating from a planet 7 trillion miles away. The source? Proxima Centauri b, the closest exoplanet to Earth, circling the dim red dwarf star Proxima Centauri. Scientists were left stunned. Could this be the first visible trace of intelligent life beyond Earth? For decades, humanity has peered into the cosmos, hoping, searching, for a sign that we are not alone. But nothing could prepare them for this. As the James Webb Telescope captured data in its powerful infrared gaze, it revealed an unexpected anomaly: artificial-looking lights coming from Proxima b's night side. The kind of glow one would expect from a sprawling alien city, quietly burning through the cosmic night. Was it possible? Could this really be evidence of a civilization, thriving in the cold shadows of a distant world? For years, researchers have studied Proxima Centauri b, curious about its proximity and potential to host life. But this new data elevated that curiosity into awe. When NASA engineers saw those city-like illuminations, they asked the inevitable question: how long have these lights been there, waiting for human eyes and technology to reach a level advanced enough to notice them? David Kipping, a Columbia University scientist, weighed in. He explained that Proxima b is particularly mysterious. Unlike most rocky planets that absorb starlight and emit expected levels of infrared energy, Proxima b's signature was bizarre. It didn't match its host star, Proxima Centauri. It was different. It was active. And thanks to the unique capabilities of the James Webb Telescope, especially in capturing subtle infrared signals, this difference became unmistakable. The JWST was designed for this very task. Its sophisticated imaging system excels at detecting faint heat signatures, especially in deep space. As it tracked Proxima b's full orbit, completing day and night cycles every 11.2 Earth days, the telescope recorded dramatic shifts in temperature and radiation. These fluctuations hinted at more than just geology. They hinted at technology. Most space-based telescopes struggle to distinguish the faintest glimmers of artificial light amidst the endless black. But JWST is different. Its sensors are so precise, they can detect man-made light sources within frequency bands 1,000 times smaller than those of natural sunlight. If a civilization is powering its night with electricity, be it from solar panels, nuclear stations, or something far more advanced, JWST can see it. What makes this even more remarkable is the suspected use of massive solar collectors on the planet's dayside. Scientists believe that if an intelligent society existed there, it would need to harness energy during the planet's constant daylight and distribute it across the perpetually dark hemisphere. Proxima b is believed to be tidally locked, one side forever facing its star, the other plunged in eternal night. But perhaps, just perhaps, not in darkness anymore. With no natural atmosphere, the planet's surface should be scorching on one side and frozen solid on the other. But the presence of warmth and light on the night side suggests one thing: intervention. An atmosphere or advanced technology might be regulating temperature and illuminating the night. That would be a defining marker of intelligent life. Webb's thermal readings showed signs of controlled heat emissions. Not chaotic, not random. Deliberate. That's what captured the scientists' attention most. Could this be a civilization unlike our own, one that evolved in near-permanent twilight, learning to adapt, endure, and eventually master their environment? The JWST, while revolutionary, can only study the few exoplanets closest to us. But as astronomers wait for Earth-based supertelescopes like the ELT to come online in 2028, all eyes remain fixed on what Webb has revealed. Instruments like the ELT will allow for chemical fingerprinting of distant atmospheres, helping us determine what gases are present, and whether those gases point to biological life or even industrial activity. But the work has already begun. The Webb telescope is capable of detecting gases like ozone, water vapor, methane, and even more critically, chlorofluorocarbons, CFCs. On Earth, CFCs are entirely artificial, produced by human industry. Their presence on Proxima b would be irrefutable evidence of advanced technology. Not just life, civilization. SETI, the search for extraterrestrial intelligence, has long scanned the stars for radio signals. But now, with instruments like JWST, we're no longer just listening. We're watching, analyzing, comparing thermal profiles, light patterns, chemical signatures. If there is a signal, whether radio, visual, or infrared, Webb is poised to find it. And it's not alone. New biomarkers like the vegetation red edge, VRE, which measures how plant life reflects light, are helping scientists distinguish planets that could support not just microbial life, but entire ecosystems. VRE patterns are fingerprints left by biology, and if Proxima b has its own, it could redefine what we think is possible beyond our solar system. In recent years, discoveries have accelerated. With over 4,000 confirmed exoplanets, astronomers now believe there may be trillions more. Some may have life. Others may have civilizations far beyond anything we've known. And then there's the TRAPPIST-1 system 41 light-years away, with 7 rocky planets, 3 of which sit squarely in the habitable zone. Webb is already studying them just as it studies Proxima b, mapping atmospheres and light curves with incredible precision. Despite its closeness, Proxima b is no paradise. Bathed in ultraviolet and X-ray radiation, it faces constant assault from its host star. Without a strong magnetic field, its atmosphere could have long since been stripped away. Yet the temperature remains in a range where liquid water could exist, possibly protected by an atmosphere we haven't fully mapped yet, or perhaps by structures that serve a more advanced purpose. Even its tidal locking, once considered a deal-breaker for life, now seems less daunting. If the night side is illuminated, if heat is being moved, electricity generated, and light deliberately cast into the void, then we're not looking at a dead rock. We're looking at a world transformed by purpose. Of course, not all scientists agree. Some urge caution. Light, heat, and chemical anomalies can be caused by natural processes. Volcanism, mineral fluorescence. But the patterns we've seen don't follow the usual rules. The signals seem designed, persistent, localized. And that raises a breathtaking possibility, one we've dreamed of for centuries. Could it be that, on a planet so close to us in galactic terms, another civilization has risen, built cities, harnessed the sun, lit up their skies, waiting, perhaps unknowingly, for someone across the stars to notice? This is not science fiction. This is science reaching its limit and looking over the edge. And as our instruments evolve, so too will our questions. Who are they? What do they see when they look back into the night? Do they see us? Or have we been watching each other all along, separated only by time, distance, and the silence of space? The James Webb Space Telescope has already rewritten history, but maybe, just maybe, it's about to rewrite destiny.